buffer queues inside the data plane. Once any anomaly detected, related servers will be isolated soon. And in addition, sufficient statistics and events like packet drops, CRC errors will be reported to control plane in real time. When it exceeds a certain threshold, the device will be removed from the cluster. And the ARM OS system is still in the rapid iteration process, and more new features will be delivered in the future. Next, I'd like to share some operational experiences from the production deployment. First, to minimize the operational error, using the centralized orchestrator instead of manual configurations on different components to configure the whole SDR system. And second, provide robust one-click operation to quickly and safely turn off the SDR system for operators when needed. And third, keep the message queues among different components reliable and efficient. As these components are loosely coupled, any minor configuration difference may cause unexpected faulting behaviors. So it's really, really important. Next, I'd like to share some future works. First, for network visibility and monitoring, we need a global view end-to-end network quality detection and analysis system for different network layers, underlay network, overlay network, and application level network. The second, based on the results of the end-to-end network monitoring, we are going to explore automatic traffic engineering by taking more metrics into consideration. Third, we plan to implement the simulation and the verification system for both the data plane and routing plane in order to detect and fix system abnormal behaviors in advance. Okay, in conclusion, by leveraging this disaggregated software-defined router architecture, we managed to provide Tencent Cloud a highly scalable, flexible, and cost-efficient cloud-scale routing service. That's all. Thank you very much.
Okay, thanks, Alan, for the great talk. So we have plenty of time for questions. Okay, I think it's a great opportunity, right? Alan, tell us a few things about Tencent Cloud Access Network, right? So for any question related to his practical experience, so this is the opportunity to ask him. So let me see. Let me see. Okay, Chen Chen, you have a question?
Hello, can you hear me?
Yeah.
Okay, thank you for giving me the opportunity to ask a question. And Alan, thank you very much for sharing the interesting practice at Tencent. So I have a question related to your underlay data plane. So you mentioned there could be up to 10 million rules. So what kind of underlay data plan you are using in Tencent to support so many rules and guarantee all the matching for the rules would be in time?
Okay, first the data plan is in the overlay network, not in the underlay network. So that's the key point. So all of the 10 million faulting rules are installed in the overlay network in our server memories, not so it's transparent for the underlay network. So no.
Okay, so can you support, so if that case, I guess you support like per flow processing, not per packet processing.
Yes, we mainly use the, most of the time we use the LPM algorithm for the traffic forwarding. For some specific cases, we use the flow-based forwarding. Yeah, I just talked
Okay, so
the
if
different
the
scenario, yeah.
Yeah, if the rules or the flow tables are kept in, accommodated in server memories, so how fast can you support the matching, the processing through that?
Okay, we have an internal mechanism to optimize the packet processing. Yes, I know that you mean
Yeah, so
so
can
many
you share
stages for packet forwarding. So how to maintain the performance and with large memory. Yeah, we have an internal mechanism. We optimize the whole packet processing continually to improve that.
Okay, so if possible, can you share us some a result or some information related to the throughput or delay related to the processing?
Yes, I just described that we can support currently
Okay.
with the, yeah. Okay, well, I can't talk too much about
I'm
that.
just curious.
Yes, I know that it's not a secret, but I can't talk too much. I think
sure,
we will
sure.
public more details about this, our design.
Sure.
Yeah, yeah. Okay.
Sure, no problem.
Thank you.
Okay, thank you, thank you.
Any other questions? Yeah. For the rest, you can think about your question. Actually, there are some questions from our audience in the chat. So let me ask Alan for them. So here's a question. So how much the cost does SDR takes in order to operate in additional features compared to a traditional router?
Sorry, how many what cost?
How much cost does SDR take in order to operate additional features compared to a traditional router?
So how much cars or class? Sorry.
Cost, expense. Cost.
Oh, how many cost?
Yeah.
Oh, you mean the compared to the traditional router, right?
Yes.
Yeah, generally as so. Yeah, this question is that generally we just take the commodity router, commodity switch. So compared to the traditional router, so the cost is a good question, but I can't talk too much about that.
All right. So yeah, it's okay. So maybe the next question, not talk about the money, right? That's sensitive. So
yeah, we'll focus on the technology. Sorry.
Okay. So are there any performance issues when you use SDR instead of hardware solutions?
Performance issues, so the first we just leverage the commodity switch or leverage the user space, networking stack, the high performance IO, and to improve the performance packet processing on our servers, and then we also introduce the hardware acceleration for our performance improvement. Yeah, okay.
Okay. So here's another question. How can non-stop forwarding and non-stop routing can actually be implemented in SDR?